Okay, so hopefully this is a not too long review video for exam 2. I've got some practice problems that I'm going to post into D2L for you. Okay, they look something like this. In fact, I think they're already posted in there. And I'm going to work some of them here, but I don't think I'm going to work all of them because some of them are just a little bit of repetition. What I might do is post a key online if you need that to kind of help yourself and make sure you've got the right answers. Remember that our exam format, it's going to be similar to what we had on exam number 1. So there's going to be some true falses, but you have to give a reason. There's going to be some multiple choices, but there might be more than one choice that's correct, that kind of stuff. So study your homework, work the practice problems that I'm putting online, and make sure you've watched all the videos because everything we've done so far is fair game. So it's not going to change at all. So there's a few problems like number 1, last year 9 employees of an electronics company retired. Their ages at retirement were. Find the mean, median, mode, and range for these data points is what it's asking for. I think that one's pretty straightforward. You just take all the data points and average them together for the mean. You lay them out in order. If you lay them out in order, then yes, you'll be able to figure out the median. It's the middle guy. And the mode happens the most often. I can tell you by looking at 61, and the range is the top minus the bottom. So I think these are pretty easy. Find the mean, median, mode, range. I'm not going to work too many of those. The questions that some people have had problems with in the past: does the mode of a data set always lie near the center? And it's that always that you should be worried about. Okay. The mode of a data set is the most often occurring data point. Okay, so it has to be a data point, but it does not have to be in the center, right? So think about it like this. Mode, if we were looking at kind of a bar graph type thing, the mode is the data point that happens the most often. So it's the tallest bar. So remember, we had some examples where we had something like this. In this case, the mode is on the right-hand side. And real quickly for bonus brownie points, this guy with the mode over here, the outliers would be on the tail over here on the left hand. So this would be a left skewed data set, right? Okay. So in something like that, that's for brownie points. Remember what that means. Okay, so outliers are way over here on the left. So in something like this, then no, the mode is not in the center. So 3, the mode, does the mode of the data set always have to be near the center? The answer is no. Okay. And then it says, explain your answer, give an example of a data set to illustrate your answer. The graph might help you illustrate, or you could do something like this. If it could be 1 and then 20, 20, 20. That could be my data set, right? Something nice and easy. It doesn't have to be crazy. Just so that the mode is on the far right side, and then we know, oh, it's not in the center. If the mode was in the center, then I'd have something more like 1, 20, 20, 20, 40, right? That would be in the center. Here, it's on the right. Okay. So if you need to give an example, draw a picture, whatever you need to do to help yourself out there. Okay. Number 4, suppose that a state introduces a state income tax which will be at a flat rate of 3%. State legislature wishes to estimate how much money they will receive in taxes, and to do this, they need to know the average income of residents of the state. Which information would be the most useful, the mean income, the median income, or the mode of the incomes? Okay. And why? Well, actually, all of those are useful because they tell you a different thing about what's happening in the middle of your data, right? The mode might tell you, oh, we have a ton of people. The most of our people are in the lower income brackets. So that means that they're not going to give us a lot of tax money, right? Because they're lower income brackets. The mean tells me the average, and that might actually give me a pretty good idea, except that if you have a lot of people in the upper income areas, they're pulling your mean up, they're dragging it to the right, so to speak, and so my mean might be there, but the lower income people aren't going to be able to contribute what the higher income people will, right? So a lot of times median is what we look at here. Okay, that's the middle. We know there's 50% above and 50% below. So it's the true middle of the data set. Okay. And so sometimes people will look at that and say, okay, we know if these are my data sets and the median is right here in the middle, I know I might have some way up here and I know I might have some way down there, but at least the median's telling me I'm smack dab in the middle. So if we go by that, we're probably pretty safe. And that's what most government entities like this would probably look at. All right, number 5 is a pretty complicated problem. So I want to look at it for a minute. The table below gives the sales price of 7 homes sold in the same neighborhood over a 6-month period. Okay, and you've just got a table, 301,000, 157, 310, 492, that kind of thing. Find the mean price and median price for these homes. Well, that's easy enough. You're just going to average these together, right? Put them in order. So in order, let's see, it would be 157,000 and then 276,000 and then 281,000 and then 296,000 and then 301, 310 and 492. So there's my 7 values, and there's my order. Okay, so the median guy would be the 4th one, 296,000, and you can find the average. I'll let you do that on your own. But here's where it starts getting a little bit complicated. Which home is a possible outlier on the high end? Well, it kind of looks like 492 is a little bit high, right? Okay, so 492,000 is a possible outlier. So we don't know that it is. We know by now. We have to do a lot of calculations to figure that out. Either you're doing a box and whiskers or a z-score or a standard deviation, something to let you know. But they're saying, let's just assume it's an outlier. If you eliminate this home, what are the new mean and median prices for these homes? So they're saying, if you dump that data value, what's your new mean and median? Well, now you're going to average those 6. That's what they're saying, right? And by the way, my median's no longer going to be 296 because there's only 6 data points. I'll pull the 2 middle guys and average those, right? Divide by 2 because there's 2 of those. Let's see what that is. Yeah, I don't know. My arithmetic's terrible. 296 plus 281. 577,000 divided by 2 is 288,500. Okay, so now the new median would be 288,500. It was 296. Now it's dropped because I got rid of this high value, right? And a similar thing will happen with your average. When you average 6 scores instead of 7 scores, the average will drop, right? The mean will drop, okay? So that's what they're trying to get at is this is the kind of thing that happens to data sets whenever you, quote, get rid of an outlier. If you think you can just dump one, then it shifts my average, it shifts my median, okay? It won't change the mode unless I happen to get rid of the data point that was the mode, right? So it doesn't mess with that, but it really messes with your mean and your median. Which home is a possible outlier on the low end? Oh, number C, part C. So on the low end, what they're saying is, hey, look, this 157 looks a little bit low. If you eliminate this home, what are the new mean and median prices of the homes? Okay, so they're saying if you got rid of this one instead, okay, then what? Well, now I've got 1, 2, 3, 4, 5, 6 here, which would make my median, the average between these two, divide by 2. I'm not going to do it right now. I just did the other one. So y'all know how to do it if it's an even data set. We're getting rid of a low one, so you can tell the median's going up. And what do you think will happen if I get rid of this low value to the mean? Yeah, in my mind, I'm hearing you say, oh, the average gets bigger too. Of course it will, because I'm getting rid of the low guy that was pulling me down. So I'm going to have these 6 scores, and I'm only going to divide by 6 instead of the 7 that I did originally. Okay, here's the interesting thing. What if you eliminate both possible outliers? What are the new mean and median? Okay, so they're saying, what if I got rid of the 157 and I get rid of the 142? Well, if I get rid of both of them, so this had 6 data points, this had 6 data points, but if I get rid of both of them, now I only have 5 data points, right? Okay, so I get rid of both of them, 1, 2, 3. My median goes back to the 296. That's interesting. 4, 5. Okay, so that goes back to what it was originally. So it's kind of like I'm bumping the low guy and I'm bumping the high guy. So it's kind of balancing out that I'm getting rid of a low and a high. And now you would have to average these 5 scores to get your new mean. Okay, so just kind of look at that and think about what's going on. Play with the numbers. Like I said, I'll probably try to post a key so that you can check yourself, just so that you know what it's supposed to look like, but I'm not going to work through all of those. I want you to think about it. Okay, that's what I'm up to here, getting you to think about analyzing data a little bit. I know we've done some homework now, and I know we've done some videos now, and you've seen me do it. Hopefully you've done some of it yourself so that you're not, you got that muscle memory going. But now just thinking about what happens inside of stuff and analyzing. Okay, number 6, the mean of a data set is always, sometimes, or never one of the data points in a set of data. Explain your answer with a brief example. Okay. Number 6. The mean. Okay. Can the mean be a data point? Let's start there. What if I had 1, 3, and 5? 1 plus 3 plus 5. Divide by 3. That's 4. 5 is 9. Divide by 3. That's 3. My average is 3, and 3 is a data point. So can the mean be a data point? Yes, it can. The mean can be a data point. Okay, we know that. But does it have to be a data point? Okay, and the answer is no. I hope you know that. What if I just had the data set 1 and 1 and 3. 1 plus 3 divided by 2. 4 over 2 is a 2. That's my x bar. Was 2 a data point? Not have to be. Okay. Mean does not have to be. Okay, so the answer is no, it does not have to be a data point. Absolutely not. Okay, this one's interesting, number 7. The histogram shows, so it can be, but it doesn't have to be. So the question, I'm sorry, let me go back to 6. Always, sometimes, or never? Well, the answer is sometimes, right? Okay. The histogram shows the lifespan of a sample of 125 light bulbs. Over the histogram, draw a smooth curve that captures its general features. Don't miss this part of this question. If I give one similar to this, you need to draw your curve. I can't tell you how many people don't do what it says, and then you lose a point or 2 because of it. Okay. So there's my smooth curve. Then classify the distribution according to its number of modes and its symmetry or skewness. Well, how many modes does it have? just one, right? So it's unimodal, okay, normal. Or unimodal is normal. It's not a normal curve, clearly, okay. Talk about its symmetry or skewness. Which one does it have? Is it symmetric? No, if it was symmetric, I'd have the other half of my graph over here, right? And I don't. So that makes it skewed. Does everybody agree? Okay. It's offside, basically. And it's skewed which direction? Now be careful, because a lot of people think the mode is pulling it this direction and the mode is pulling it that direction. But remember, what we're looking at for skew is what's going on with the tail. The tail has an outliers down here, possible outliers. Possible outliers are down here, and they're the ones that are pulling this tail out, right? So when I talk about that, it's a left-handed skew, or a left skew graph, okay? In words, summarize the meaning of your results. Okay, so let's think about this. These are light bulbs. There's 125 of them. And what we see is that some of them burn out in a matter of just a couple of months. Time and months. Okay, 2, 3, 4, 5, 6. Not a lot of them, but some of them are burning out early. But most of them are making it 10 or 11 or 12 months, right? Okay. So what we think is that we would expect our light bulbs to last probably somewhere between 10 and 12 months. Okay. However, we have a few that blew out early, and so they are causing the graph to have this really long left-handed tail. Okay. That's what's going on there. Okay. All right. It doesn't, is it normal? No, it does not look normal, and the reason why, again, is because it's not symmetric. All right, so those are the kinds of thinking things I want you to start doing. So think a little bit about that. Number 8, histogram shows the weight in grams of 98 casino poker chips. Over the histogram, draw a smooth curve that captures its general features. Again, don't miss this. It's a very easy point to get, so there's my curve. All right. Then classify the distribution according to its number of modes. You know, it's interesting because to me, there's only one mode here in the graph. However, because this is the most. However, I can tell what they're trying to say to me is that this is a 2-hump graph. Okay, this one's not as tall as this one, but I think that they're trying to say, look, we got a kind of a cluster of poker chips here, and we've got a cluster of poker chips here. I still think there's only one mode. That's me personally. Some people will say there's 2 modes because there's one on the left-hand side and one on the right-hand side. Inside of this group, that guy right there is a mode, but it's a relative mode. So if you've taken a calculus or an algebra class, you know that there are some relative maxes and relative mins. Okay, so this is definitely the mode for the graph. Okay, but this is a relative max that's going on here. Like in this, if I just look in this area, definitely there's a tall point, right? Okay, so modes, it's symmetry or skewness. Well, it's actually a lot of the data right here, and then it's got this weird conglomeration of stuff over here on the right hand side, because we're going to talk about that in a second. Okay, so it is right hand skewed. Does that make sense? Right tilde, right skewed, because the most of my data points are over here on the left, and the ones that are probably outliers are down here on the right. So the right hand is what's messing me up. If it wasn't for that right hand thing, this would actually be really nice and symmetric, right? We'd probably say, oh, that's very symmetric, that graph right there. It's these little guys that are causing me a problem. Okay, so let's think about it. These are supposed to be 98 casino poker chips. What feature of the graph reflects the fact that 21 of the casino poker chips were found to be counterfeit, whereas the remaining 77 were genuine? Okay, so let's think about that. These are real. Okay, 77 of them. I know that that's the real ones. These 21 over here are fake. Okay. So what is it that's telling me that those are fake? It's interesting. Their weight is just slightly too much, right? And so they're making their own little conglomeration of data points here that set up their own little thing. That's why if you looked at those, inside of these fake guys, it's kind of a normal curve also, right? So they've got their own little group down here. So it's this right tail has all the fake poker chips. So it's the fact that they're skewed. If they were all real, we would expect it to be a normal data set, right? We would expect it to look real, normal. So it says, what feature of the graph reflects the fact that 21 are counterfeit? It's that skew. It's that long tail that says, oh, these guys are outliers, they're weirdos. And they really are weirdos in this case because they are counterfeit. So they do not belong. So those should be kicked out, right? All right. So looking through, you can kind of play with some of these data sets. State how many modes you expect to find in first grade weights of first graders. Well, normally we would expect all first graders, they're probably about the same, right? The hormones haven't kicked in. Boys and girls kind of look still about the same height and same weight and all that kind of stuff. So probably in first graders you would expect just one. Once we get to where guys are kind of bulking up and getting more muscle and more weight and taller and all that kind of stuff, like middle school, high school, we might expect two, one for boys, one for girls. But in first graders, you probably got just one. Okay, identify as symmetric, left skewed or right skewed. I want to talk about this one because this one seems to bug people. So we're going to actually do some of these. Number of days worked last year by adult males. This is number 10. Number of days worked last year by adult males in the U.S. city, which has a low unemployment rate. Okay. If it's low unemployment, then we expect them to work a lot of days. Does that make sense? That means everybody's working and we expect them to work a lot of days. So as I look at this, I'm looking at number of days worked. Number of people. Okay. U.S. city which has a low unemployment rate. So as I come out, let's say this is 50, 100, 150, 200, 250, 300. If you consider there's 300 362 days in a year, and 365 days in a year. Sorry. And 1/4 days in a year. Okay, so you expect, most people don't work every single day of the year, right? Most people have weekends off. If you consider that, even just people working 5-day weeks every week, 2 days on the weekend off times 52 weeks means they have 100 days off. Does that make sense? Even if all they get is weekends. And we're talking full-time employees, right? Last year by adults. Nope, it just says number of days worked last year by adults, adult males in the U.S. city. Okay, so if they have 100 days off because of weekends and then they get a few days here or there for vacation or holidays, Christmas, New Year's, whatever, then probably I would expect most people to work somewhere between 200 and 250 days. And different groups, might do different things. So like teachers may not work as much because they have summers off and stuff like that. But if we're working a lot of days, I would expect most of my people to be somewhere in here. And unemployment is low, so I don't expect a lot of people who are at 0 or 50. Okay, so what do we think about that? It's probably not symmetric. There's probably not a lot of people coming down here. So what would this be? The outliers are down here, left skewed. And that's because unemployment's low. If it was flipped, if unemployment was high, I'd expect there to be a lot of people who aren't working a lot and then not so many people working 250 days, right? Let's look at another one. Shoe sizes of adult women. This is one of those naturally, genetically controlled things, right? So here's my shoe size. Here's the number of women. And it's just adult women, it's not kids, and it's not men. Okay, so of course we expect most of them to be kind of right in the middle, and we expect some small feet, we expect some big feet, and so this is more symmetric, right? Remember, those things that are genetically controlled, like hand size, shoe size, weight, height, things like that, all of those things are generally, not always, but normally symmetric data sets, especially if these are all women. Like, it might be different if it was men and women. We might have 2 modes or something like that, but not if it's just women. Okay, and number 12, exam scores for an exam in which most people did very well, but a few students failed. Okay, so again, these are my exam scores. We might have some people down here at 20s and 40s and 60s, but it says most people passed. So maybe they're all up here in the 80s and 90s. But I do have a few failures. So what do we think about that? High scores, number of students, frequency. Yeah, again, this looks left skewed to me. Now, if they had said the average was around 70, a few people made hundreds, a few people made zeros, then we might talk about it being symmetric. Or what if it had said a test where most people failed? Well, then the mode would be over here, and we'd have a few people up here, so maybe then it would be right skewed. Okay, so you got to look out for those. Okay, obtain the 5-number summary for the given data, and it says max, min, median, Q1, Q3. Again, just do this mathematics. I expect you to be able to do this pretty easily now, finding all of those things. If you're having issues, let me know. Show work that details how you would find the mean and the deviations from the mean for each data set. Now, this is the beginnings of standard deviation. We're not asking you to actually do the whole standard deviation. We want you to find x bar, which is the mean, and x sub I, each individual data point, minus x bar, right? So deviations from the mean, that's what they mean by that. Okay, but we are not asking you to go ahead and do the standard deviation. Okay. Number 15, find the standard deviation for this given data. Round your answers to 1 more decimal place than the original data. Researchers at the State University conducted experiments with tomato plants. Listed below are the weights in kilograms of tomatoes given no treatment, those given the fertilizer. How much does each data set vary? Compare the variations in the 2 data sets. Okay, so these are little weird data sets. So here's a data set and here's a data set. There's 2 different ones. So for each one, they want you to find variance. So how much variation is going on in there? Remember, we got several measures for that. You might look at range, you might look at variance, you might look at standard deviation, but it also says find the standard deviation. So make sure you do that. It's a long process. 16, construct the box plot. That's box and whiskers. Test scores of 32 students are listed below. Draw a box plot for the data. Give the 5-number summary. Make sure you can do that. That's the max, the min, the median, the Q1, and the Q3. That's really important that you can do all of that. You will for sure see it on a test. Okay, and the following data shows the deaths due to the same disease in 2 cities. Compute the death rates for whites, the death rates for non-whites, and the death rates for all residents in both cities. So explain why this is an example of Simpson's paradox and how the paradox arises. Now, for some of you, we may not have talked about Simpson's paradox. If we didn't, don't worry about it. It won't be on your test. But for some of you, I'm trying to get that video made and post it. So you will have to tell the difference. So the death rate in city A, the death rate in city B for each of these groups. And basically remember that the idea behind the paradox is it might look one way but be another. So it might look like the death rate is, for instance here, it might look like the death rate is worse for white people because it's such a large number, 1,800. But when you compare that to the 750 people that are the population of City A, it might be that the 120 for a smaller population of non-white people is worse. And of course, what's the death rate for the overall city? So, yeah, think about that. If you haven't done Simpson's paradox yet, then don't worry about it. If you have, then remember a paradox is something that looks one way but is really another. Okay, so in other words, it might look like the white people have more deaths, and they do, in general, especially in City A, have more deaths, but it could be that percentage-wise, the rate of death per white person is not as high as the rate of death for non-white people. So you got to check those things. It's not enough just to look at the raw data. Sometimes you got to do a comparison. Okay, so that's kind of the idea behind these practice problems. Again, these are just practice problems. That does not mean that that's all that's going to be on the test. I can throw other stuff at you, especially if it's stuff off of videos or off of homework. So please, please, please make sure that you are all caught up on your video watching and your homework doing so that you will be prepared for the exam that's coming up soon. For most of you, it's probably in 1 week. All right, I'll talk to you later. Let me know if you have questions. Thanks.